So hi everyone. Well, hi everyone. So this event is brought to you by Data Talks Club, which is a community of people who love data. We have weekly events. This event is one of such events. If you're interested in all the events we have, go to this link and you'll see a list. Right now there are only 3 events. Actually, we have more like 10 events scheduled. I just didn't have time to put them out yet. So watch out. You'll see more events coming there soon. So go there on this link and you'll be able to register there. Then, of course, if you haven't subscribed to our YouTube channel, do that. This way you'll have all our new videos in your YouTube feed. If you check feeds, I don't know. I didn't know actually YouTube had a feed until recently. So yeah, they have a feed. So subscribe to our channel to get our videos in your feed, and then of course join our amazing Slack community to talk about different data related topics. And then the last thing, during today's presentation, you can ask any question you want. There is a pinned link in the description, in the live chat, sorry. So go to the live chat, click on this link and ask any question you want, and we will cover these questions at the end of this presentation. So Emil, the floor is yours. You can start.
Let's start.
And welcome, by the way.
Yeah, thank you. So let's start. Today we're going to discuss PyTorch Contributors Guide, how and why, how one should do it and why. The outline of today's report will be the following. We will cover why participate in open source is important. What is PyTorch as a project, and how to work with its issues, how to find the issues to resolve, and how to find a way to contribute to PyTorch. And at the end, we will talk about some technical details about my experience in contributing to PyTorch. So it might be hard because it's technical. Let me introduce myself. My name is Emil Bogomolov. I work as research engineer at Skoltech, and that's basically it. You can find me on LinkedIn or in Telegram. I haven't added here, but in LinkedIn you can find me as Emil Bogomolov. So why should I contribute to open source? So I highlight 4 points on that. First point is to gain a confidence as a developer. What I mean, at this point I talk about an abstract novice programmer who sees his or her as me and sees developers of large, widely used frameworks as them. And it is quite discouraging. Firstly, for a novice programmer, open source creates opportunity to get development experience with feedback, which leads to a better code. And secondly, it is great teamwork practice, creating good pull requests, working with reviewers and reviewing others. It is a teamwork. With open source development, one can erase the boundary between small me and huge them through collaboration. Because when you work with these people, you understand that you are similar and you can do more. The second point is work for your resume. By that, I mean that with open source development, you may have a different source of accomplishment that can be added to your resume or on par with your main job. For example, you do something with gradient boosting on your job, and you put that you work with XGBoost and you understand everything about it. But if you do not work with neural networks, you can go open source and do some stuff with it and also put it in your resume. And in particular, you can try and apply technologies that you don't use in main job and to develop a portfolio in your GitHub account. So when you do something on your work, it might be very private, everything that you do, but you can share the knowledge on open source projects and have it on your public page in GitHub. The third point is to expand the professional network. Good connections give you great benefits. And I'm not talking about schemes of corruption when some individual get a highly paid job without fair competition. Sounds familiar, huh? I'm talking about possibilities that are open up when you work in a big distributed team of developers. So the basic thing, you know who is doing what in a field that you are interested in is the first benefit of professional networking. You can find places and groups, for example, scientific groups or working groups that utilize stuff you're interested in. Um, the third point is you can influence with your opinions and share your knowledge and also influence with that. And there is always a big chance to be noticed by maintainer or recruiter that come to this open source project and be proposed to continue work, but for the real money. Separately, in a different color, some kind of external goal. So when the green ones is internal goals to improve yourself, the fourth is more uh, external. And what is about? By this, by no, I make such point as to be involved. Yeah, by this I mean to be involved in the positive impact that open source has on development of technologies and how it improves the quality of human life. I'll give you two examples of open source that helps us. First, the company Open Insulin. They are developing an open source way of creating insulin. This will reduce the cost of insulin dose for end user, which is crucial in a world where number of patients with diabetes grow along with prices for the dose. So it is very crucial to have a cheap insulin. And while today's insulin is protected by patent, uh, it is needed to create an open version of it. The second example is 50 years ago, Volvo car manufacturer developed all-known seatbelt that we use in our cars and opened this patent for any manufacturer who wants to use it with no royalty. Since then, these seat belts saved a lot of lives in different situations. This is also a open source, kind of open source. Uh, let's go forward. Let's talk about PyTorch as a project. So, PyTorch is a framework for fast and agile experiments in deep learning. It is obvious. And recently it has begun to acquire a deployment potential. Here, the picture of some researchers from Delft or Delft. Um, it is from 2019, and right now PyTorch is more complex, but at that time it wasn't full. It's just an example of how PyTorch looks like as a project. There are different submodules that you can work with, and some layers, 3 layers of implementation uh, that is written on the different languages. So the top level is Python library of PyTorch. It exposes easy to understand API for users to quickly perform operations on tensors, build and train deep neural networks. This library provides interface but doesn't really execute the computations. Instead, it delivers this job to its efficient computation engines written in C++. And in C++ level, we have module A10 that is based on um, lower level C library that does um, efficient computation with tensors and mm, algebra with multidimensional arrays and algebra. To understand how PyTorch looks as a project, you can visit this second link, PyTorch module structure model uh, from the university to Delft. And the third link is the link of podcast of one of maintainers of PyTorch, Edward Young. He talked about the concepts that is used in PyTorch in different submodules and why they decided to go with these concepts, not the others. So let's talk about how to find an issue to resolve in a project, how to start contributing to it. Okay. In essence, your contribution is the code that solves the issue in the project. Issue can be of two characters. The first, they might be already exist before you, like here on the board, or you found one and proposed it, or proposed some functionality. So, which use cases might occur? You were doing your job and came across unexpected behavior of the framework. For example, expected one thing at the output, got another. And you tried to meet all the requirements for correct execution, and the calculations fall with an error. There might be a bug. The second option, according to the project, you can see that the development of the features is underway. So, what I mean? I mean that someone starts to implement things, but you cannot understand how to use it. For example, how to overtake Torch Vision models in ONNX. At the end of 2019, there was a problem to convert Torch Vision models to ONNX. And for example, to convert quantized networks in ONNX. This problem still persists. You cannot directly convert PyTorch quantized model to be transferred to another framework, only to Cafe2. So what is on the slide? Here on the slide, you can see the PyTorch issue creation, 2 stages. First stage, you try to solve the problem by addressing it to community through the Discuss forum. There is a Discuss forum where you can ask your question or answer someone other's question. There is a constant discussion about some new features, bugs, and mostly about how to use the framework. Specialists who are maintaining some projects can give answers regarding which usage is expected and whether the behavior you have detected is a bug or not a bug. So here I want to mention that when you answer the questions that is occur on the PyTorch Discuss forum, it is already a contribution. So you help other developers to gain skills and to solve their problems. So it is the first stage. If developers says that what you found is a bug or the feature that might be interesting for other users, you can go to GitHub account of PyTorch, GitHub repository of PyTorch, and open the issue. After you're opening the issue, it will be moderated and sorted in the project. So if you go to this section and create issue by itself, without this step, it might be just erased, deleted. Thus, when reviewing issues on GitHub, this two-stage process guarantees that it is extremely likely that you will find exactly what could be implemented. So you can go here and start to implement it. You can be confident that this functionality is needed. There is also a sorting stage of the issues. It named triage. So it is better to look at the features and issues with the triaged tag. It means right now it is now relevant to some project. So, how to find and solve an issue? It is a great question. Let's try to answer it. First, you need to do is determine the part of the project that interests you. For example, it may be a Python API, or it might be a Swift API for mobile neural networks on iPhones. Choose the part where you want to improve your skills, if you're looking for improving skills. Maybe it's numeric algebra, and you want to understand how to write efficient algorithms in C++, for example, and C. Or maybe you are eager to put somewhere design patterns you recently learned, and you want to put it somewhere because you now understand more and want to share it. Second thing you need to is to decide on the goals of your contribution. What you want to do with this? Maybe your work, your job, depends on something not implemented publicly, and you want to open up it to public for others to improve it. Or you seek for improvement by yourself, or just for fun, and you like to read source code as a book before you sleep. Then you need to decide on the degree of involvement. It is not a full-time job, so no one will control you. And if you say that you are going to implement this issue, someone will answer you that okay, and never come back with the question, where is it? When you go to Discuss forum and PyTorch issues, you can take a closer look at those who often make changes to the project and contact the developers on Discuss forum for advice. They really open to giving an advice for you if you are interested in the development. For example, podcast of Edward Young is aimed for this. So here what we can see, it is a screenshot from the PyTorch repository. Developer offers to undertake the issue. but do not give up on implementing the solution. So if someone says that I'm going to implement this issue or the solution for this issue, it is 95% chance that it won't be done. So you can go and try yourself with this issue too. And anyways, there are always plenty of issues that are unassigned or even not commented with I'm undertaking it. Uh, which issues to start with? There are two tags. First is good first issue on GitHub and enhancement tag. These issues and features that are not very crucial for the framework, but you can implement them with convenience. So you can go and try with these issues to start diving into the PyTorch code base. It might be interesting for those who only work with high-level API to understand how it works internally. But sometimes neural network developers really don't know what is going inside PyTorch uh, if they use just an open API of the PyTorch. The second way to contribute is to decide a sub-project you're going to work with. Here is the board that is available on GitHub repository. It is quantization project board. Here you can see the three columns of tasks that are in different state, and you can go and understand what is going on in each of these columns and try to implement something here. So if you are interested in quantization, so you can go and try yourself in quantization. It's obvious. That's it with the general part. Uh, the following section will be more technical. I will talk about my experience in contribution to PyTorch. So let me describe the background of a problem. We in our laboratory um, work on the following project. We tried to solve the dense pose task, the task introduced by Facebook in 2018. It is about predicting of 3D geodesic coordinates of a person pose from a 2D image. So here you can see a footballist, uh, an image of two footballists, and then after the model works, it gives us the geodesic coordinates of the each body part. For example, here on the body you can see the grid, yellow and red, the points that are very distant from us, and the green ones is very close for us to us, geodesic coordinates. So this task may be solved by multi-head image segmentation network that outputs four output tensors. Um, it can be built on the basis of a two-stage detector, such as Masker CNN, widely known. And our work was to make this network more, this to create a network, not the initial one that Facebook provided, but other one that is very light in terms of weight of the network and very fast in terms of utilization of mobile phone chip. Yeah. So how to achieve such performance? First of all, you need to use very lightweight neural network backbones and do some tricks with the trained neural networks. For example, we tried to use quantization. Shortly on quantization, what is it about? It is about converting float float mm, tensor weights of neural networks to integer weights. That leads to four times less used footprint of the network, and it sometimes up to four times faster it end up with sometimes four times faster networks. Uh, Fortunately, at that time, PyTorch already proposed their quantization technique, quantization framework inside the PyTorch, and I used it to quantize our best lightweight model based on EfficientNet. So we decided to go with the library implemented with PyTorch that is named PyTorch Image Models, also known TIM. It has EfficientNet model that is based on the following. In the forward method, it has forward hooks that is used to store the features that we obtain on different stages of a backbone. It is needed to create a feature pyramid afterwards. And when we just take this network and pass it to the quantization framework, I faced an error that these hooks that was introduced in the PyTorch image models are lost. And I go to discuss forum and proposed the solution to this problem. Uh, Once again, the problem is when you do quantization, the post-forward and pre-forward hooks that helps you to alter the input and the output of the neural network and maybe log the tensors statistics. Uh, it was broken when you do quantization. It was completely lost. And when I proposed the possible solution to PyTorch Discuss forum, maintainer said to me that I can go and implement this feature in PyTorch. This was quite a challenge. I didn't expect it, but I accepted it and go to implementing it. So, what is the proposed changes? This is the slide from our paper, the diagram from our paper. It just basically shows that when we do quantization, it is two steps. First step, here is the first step, we fuse the modules to one intrinsic module. For example, you have convolution, batch normalization, and activation. Uh, you can fuse them in one module named conv batch norm relu, for example. And even on this stage, the pre-forward hooks and post-forward hooks were lost. I proposed the mechanism to move them from the start of convolution here and from the end of activation here to the end of fused module. So, for example, if batch normalization has uh, hooks, it still will be lost, and it is needed to remember it if you want to do it. So what the solution basically do? It handle preserving user-defined hooks, and when we do swapping the intrinsic layer with quantized one, it also preserve the hooks. And by the way, we need to preserve the quantization observer hook that is needed to compute the statistics of quantization. Let's go to exact solution. It is not big. It contains of 3 alteration in PyTorch code base, uh, but for some it might be not clear what is going on here. You can go to the pull request and see which files were changed. So for the first step, we pre-register hooks on Fusion. Then we register observer hook that was there before me um, to be first in the queue. And here I used the move to end method of ordered dict that was introduced in Python 3. And it is very interesting that before my pull request, PyTorch decided to give up the Python version of 2, and I can easily use any functionality that is available only in Python 3. It is very interesting interesting difference between versions of Python 2 and Python 3, and how open source frameworks should maintain both of them if there are 2 versions of a language. So fortunately now everyone use Python 3, should use Python 3 since 2020. Okay. The third thing is to re-register hooks when replacing modules with quantized one. It is very similar to this, but on the different part of the code. And compared to alterations that is done in the exact solution, there are more alterations that is done in tests. When you add functionality to a framework that is big and distributed, you should cover each functionality you added with tests for others to understand that it is doing exactly what it is needed to do, and to pass all the tests that are already there for continuous integration. That's it with the solution. Let's go to timeline. How it is going from the start of detecting a problem to a final step when we merge our changes to a project. It is started at the start of March. I've detected a problem and sent a message in Discuss forum. Then after approximately 2 months, I find the time to and motivation to do the first iteration of my changes. And a month later, I get the first feedback that I needed to implement the tests on my functionality. After that comes the second iteration with when I added the tests, understand that what was wrong with the previous code, and 20 days later, first reviewer came and said that there are some fixes. I fixed them, and after that, the second critic came and gave his or her um, complaints about my code. So in this framework, and sometimes in any framework, it is needed to have 2 approves from the developers to be merged in the master. So here it is also the case. Two approves, and then in 20 days, finally, GitHub bot of Facebook merged my branch to a master. And this change was listed in the version of PyTorch 1.7. So here's the timeline. And that's it for today. Thanks for your attention. I'd like to answer your questions if there are ones. There are some.
Yeah, thanks a lot. So while watching your presentation, I had a question. I think you partly answered that. So the
Yeah.
question I had was how important it is to know C and C++, because one of your slides was showing that, there are so many, C, C++, these native components.
Yeah.
Yeah, exactly. So I see a lot of C and C++ and CUDA here. And my initial thought was like, okay, if I want to contribute, how important it is to know all that. But then you walked us through your contribution. You showed how
Yeah.
you did this. And I didn't see any C++ code,
Yeah,
right?
it's completely Python code.
Mhm. Okay,
Yeah.
so it means if somebody wants to contribute to PyTorch, they don't have to know C, C++, CUDA, and all that,
Yeah.
right?
Yeah. There are a lot of concepts behind the Python API uh, in C and C++ that is needed to understand even if you know C and C++. It is very hard to go into with only Python knowledge, but there are a lot of issues that are opened to Python part of the framework, and it is Python first framework. So uh, there are many new functionalities like Torch effects and mm, Torch function magic module that is only uses the Python,
Mhm,
so you can contribute there.
mhm. So you also don't need to know Lua, right?
Yeah, yeah. Lua is, I think, is lost from the project already.
Okay.
But if you are interested in Java or Swift, there are modules that work with the mobile development of deployment of neural networks, and you can try yourself there. There are also tasks.
Mhm. Yeah, thank you. And other thing you mentioned that in 95% of cases, when somebody says, okay, I'll do this, I'll take this issue and I will solve it, you
Yeah,
mentioned that often they actually don't end up finishing
yeah, yeah.
working on this. Do you know why this happens? Is it because it's too difficult and or just, yeah, do you have any ideas?
Yeah. It is needed to be very initiative. Even the issues that has pull requests are not visible to maintainers. They just omit them when they go through if they are not very crucial. So you need to ping the maintainers to see, to have a look at your implementation.
Mhm,
So uh, if you go to PyTorch and look at the issues, you'll see that almost any issue has the message like this, like absolutely I'm going to implement it, but then no one implements it. And I'll talk to the developer in private messages in discuss forum. He said that go ahead and re-implement even if there is an implementation, because if it is it isn't an internal contributor like Facebook employee, uh, it is very highly that it isn't be done. It won't be done.
mhm. Okay, interesting. So, and that's why I guess for you, you showed the timeline for your pull request. It took some time, right? A couple of
Yeah,
months. So did
it
you have to constantly ping them and take a look?
between this date and this date, I'm constantly ping them in different places in Discuss forum and PyTorch itself. Maybe they have another tasks. Maybe they just I won't I wasn't visible for them. But after that, it go very fast.
Hmm. Okay.
So I implemented the solution and get the first feedback in almost a month.
Hmm. Okay. Are all the main maintainers Facebook employees, or there are some people who are not from Facebook there who are like
Yeah,
core maintainers?
there are a lot of maintainers from the Microsoft part that do stuff with ONNX
Oh, okay.
and some uh, core maintainers that not affiliated with PyTorch or Facebook.
Hmm.
As I know, PyTorch is part of the Facebook, but
Hmm.
not the core team of Facebook. You
Hmm.
know.
And before PyTorch, the plain torch, the one with Lua, it wasn't a Facebook project, right? It was some university project.
Yeah, it was a university project, and someone decided to re-implement it on Python.
Hmm.
Some of them.
Yeah, interesting. Do you know any other open source projects that are friendly for beginners? Somebody who want to start contributing to open source. Yeah, maybe there are other projects that you can recommend them to try.
I'd recommend to try to find something in your field. I trying to contribute to Detectron 2 code base. It is about detection models with PyTorch. So I'm always in this field with this particular framework. For example, Flare or Hugging Face frameworks are open to contributors. Torch 3D also they are always seek for implementers of papers in 3D computer vision. For example, there is uh, the paper OcuSeg, as I remember. It implements the segmentation in the 3D, but it isn't implemented in Torch 3D. So you can go and try to implement it. Because many papers won't provide a code. It was before, but now it is a bad practice to open up a paper but won't show the code. Reveal the paper but don't show the code. But when it is the case, when the paper goes to conference and there is no code, there is a possibility to implement and to contribute to some framework.
Okay, interesting. Thank you. There are no more questions. Do you want to add anything before we finish?
Oh, no. From my side, that's it. From my side.
Okay, so you said the best way to contact you is LinkedIn, right?
Yeah, LinkedIn, yeah.
Okay, then thanks a lot. Thanks for presenting this, for telling us how to contribute to the PyTorch. Thanks for sharing your own experience
Thank you.
to contributing, and thanks everyone for joining us and for watching this.
How much them
Sorry.
here? How much them here
How
in
many people
YouTube?
you mean?
Yeah,
Yes,
yeah.
there are 7 people are watching now.
Yeah, some people.
There are 20 likes, so maybe I don't know, maybe more people are actually watching. So the counter on YouTube is always strange. So 1 minute it's 7, the other minute it's 15, and then it can be 5. So I don't know. I think it's not really exact. It's
Mhm,
approximate. You know, maybe
mhm,
some they use some sketching algorithm like. Uh, uh, I don't know. There are like these inexact data structures that give you some approximate number. So I think they use something like this.
yeah.
So I don't know. I will know that after we finish the stream, so I'll know how many people actually watch, because there they show the exact stats.
Okay.
Yeah. So thanks.
Thank you.
Yeah. Have a great day, and thanks everyone as well. And you also have a great day. Have the rest of the